Hello world, good morning, good afternoon, good evening. Welcome back to codingscientist.com. We are in a very beautiful series called Raspberry Pi Pico using MicroPython. Well, this is basically a zero to hero series, guys. This series is specifically meant designed for those who are absolute beginners at a zero level. Probably you can learn basics of Python in this tutorial. You can learn basics of electronics and sensors and microcontrollers using Pico. Alright guys. So in this lesson, in lesson number 13, I'm going to show you how to connect a joystick. Joystick is a very important piece of it's a kind of sensor, right? It's a sensor, or you may call it as a device, which plays a major role in robotics field and any of the entertaining field as well, right? You can use joystick control for different varieties of purpose. So I'm going to show you how to read the values from the joystick input using analog to digital converter. All right. So basically, you'll connect. Let me show you a quick circuit drawing, and you may follow this along. So basically, if you look at this drawing, it's pretty simple and straightforward. Just about one, two, three, four, five different pins. That's all. Straight jumping into your Pico. So if you look at the wiring connection, basically ground pin is connected to the ground pin of Pico. Maybe I can show you the way I connected, so you will have an idea of what we are talking about. So this is the joystick I am referring to. This is the joystick. So those of you who are from Arduino world will definitely understand what this is. But for the first time, first comers, newcomers, this will cost you probably what about 30-40 rupees, Indian rupees. You may source it anywhere, online, or any of the malls. So go ahead and procure this, and you will need about five different jumper wires, and of course the breadboard and your beautiful Pico. Alright guys, so let's get started. So look at the circuit drawing again. If you compare this with our architecture drawing, so again I am repeating, guys, do not get confused with the physical pin 1 2 3 4 5. You need to look at the green marks like GP0, GP1. GP stands for general purpose. GPO, general purpose output is GPIo pins, right? So you need to refer to this pins, the green mark pins, and that is the exact number we need to use, not only for the circuit but the exact number we will be using when you are programming in MicroPython. Alright guys, so go ahead and start building this particular circuit the way it looks exactly. So the ground pin is connected to ground pin, and your positive 5 volt is connected to 3 volt 3 output, that is the physical pin 36. Yes, a 5 volt joystick will work with 3 volt 3.3 volt as well of Pico. So it's not a big magic. And the VRX pin in the joystick will be connected to your GP27 pin, which is also called ADC, analog to digital converter 1. Okay, which is a physical pin 32. That is the physical pin 32. And the VRY pin of your joystick is connected to your GP26 pin of Pico, which is nothing but your ADC 0. Okay, ADC 0, which is physical pin 31. And the SW pin of your joystick is connected to GP16, which is a physical pin 21. So this would probably work with most of the GPIo pins. It's not a big deal. So compare these pins, all the 5 pins, with the pin architecture. You will understand. I am looking at all the green marks here, all the green pins. So that is the way you are going to map it. All right. So basically the analog thumbstick, it's effectively three different devices in one potentiometer. If you see the potentiometer, which I showed you in lesson number, I think 2 or 3, where we control the brightness of the LED. So if you put together 3 different potentiometer in 3 different grids, that is how your joystick, your thumbstick basically works. So basically one single potentiometer for X axis and another potentiometer for Y axis, and a digital momentary button, which is the middle one. When you press down, that is the another axis, that is another potentiometer as a push button. So that's how it works, and we will take a look at it, what kind of code we need to write for this. So I'm going to open up my IDE and let's write some basic code to see how it works. So let's see. All right, I hope I am connected. All right, I am connected to my Thorny IDE and my Pico is connected as well. So let's take a look. All right, so let's see. Okay, now first and foremost, we need to, of course, import the machine. From machine, we import the pin and ADC. ADC is analog digital converter, which is again inbuilt within the machine library. You can call it as a library or you can call it as an inbuilt function within MicroPython. So let's go ahead and start doing that right away. What's happening to my Thorny? It's getting hung. Maybe I may have to close and restart. Let me just try it out. Well, yeah, okay. So let's go ahead and import from machine import pin, P in uppercase, and ADC comma ADC in uppercase, and then we will import U time, same like last time. Then we will basically use the U time dot sleep function. That is the function which we used last time as well. In the previous lesson you would have seen this function, and later basically we will try to put necessary delay, the required delay which is required, into the loop, which reads the button as we press. When we change the state, it will change. So that is the delay function which will come into picture. So now we need to basically create x-axis and y-axis variable and assign them to the GP pins of 27 and 26 as per our circuit. So how do we do that? This is how we are going to do. So let's say x-axis, x-a-x-i-s, like that. X-axis equals to your analog to digital converter pin. Pin should be in uppercase, P-I-N, P should be in uppercase, and again parenthesis. Inside that you have to put the pin number and then close the parenthesis once again. Same way for y-axis. Y-axis equals ADC in uppercase again, and P is uppercase pin, and we assign the y-axis to pin number 26 of Pico. Close the parenthesis, and now we need to create a button, basically to act as a variable. So the button variable, and then assign it to the respective pin as an object. Okay, I talked about object, how it works. For every pin you need to consider that as an object in Python. Now let's say button equals to pin number 16, and then pin dot in, comma, we are reading the input from pin 16, and then we need to pin dot pull underscore up. We will pull up the resistance value from that. All right, pull up, yes, correct. And then now that the pin object has basically three different arguments: the GP number, the mode, which is basically the input. In our case, we will send an input through the joystick, and whether it has a pull up or pull down resistor, we don't know, but we want it to be in an input mode and a pull up mode, right? So that is how we need to think logically. So now for that, what we need to do, now we also need to create a continuous loop that will basically check and print the value of your x-axis and y-axis and the middle button of the joystick as and when we change, right? So how do we do that? We need to bring it into the loop. That is while true, hit enter, and then x value equals to x axis dot read underscore unsigned 16. Okay, that is the unsigned integer value, unsigned 16. Then y value equals y axis dot read underscore unsigned 16. Okay, and then the button value equals to button dot value, like that, and close the parenthesis, because that is what you are creating within the object. That loop has to repeat again for the button value as well as for x axis and the y axis. And now we will print the output, print the string of the output, the string of x value, okay, x value plus comma in a double quote, and then plus the string of y value plus in a double quote we will just put 2 minus in a double quote plus the string value of the button value, and now we'll close the entire parenthesis, right? So what we are trying to do, we are capturing the string value of the x-axis. When the x-axis you move the button, the value is captured, and then again we are adding that to a string value of y-axis. When you are changing the y-axis, the resistance will change, and obviously the reading will happen. And then plus we are adding little bit of space with a string value of button value, that is when we are pressing it. Now let's add a time, time dot sleep of 0.1. okay, now I hope this code run, guys. Now basically we got to try it out, and actually we need to check whether if we need to put the status as well, like middle or center or left. I think it will be a good idea. Yeah, let's do that. If we put a status, like we are whether we are pressing a middle or a left one or a right one, let's go ahead and do that, guys. Let's create another variable within the while loop. So let's say x status equals to middle, x status equal to middle, then y status equals to middle where nothing is happening, and then the button status equals to, say, not pressed, and then if we basically then use the statements to correctly label the joystick, like which direction we are moving, and the button status within the loop, right? So how it should happen, basically we need to say if your x value is less than or greater than, less than or equal to 600, then what should happen? Then the x status, we declare the value already, for the x status should show as left, like this in a double quote. And then else we'll use elif x value is greater than or equals to, say, the value, resistance value of 60,000, that is 6K, colon. So what should happen? The x status equals to right, like this. Oops, what happened? Equal to right. And then we will come back to the if statement again within that same indentation of elif. If y value is less than or equals to, say, 600 again. 600 colon, then what should happen? The y status should change. Y status equals to up, like that. And then we will come back to elif again. Else if y value is greater than or equal to 60,000, then the y status equals to down. So it will basically print, right? And then if button value, that is a variable which we declared already, button value 0 equals to button status equals to pressed. If we keep pressing it, then what should happen? Now basically, now what we need to do is use a print statement to print the variable and place it above the sleep command. So how do we do that? So we need to come out of that and say print, like this. Now we will print, say x, let's put it in uppercase, x colon, and then in a double quote plus x status plus right, it makes sense, and then comma y in uppercase, y is to y status plus, and then we'll close it with the quote and a space button, and then say we need to add button status plus button, let's give a space here, button status, like that. All right, now let's see. I hope there will be definitely some mistakes. Let's cross our finger. So we are printing the status as well. Let's double check from the beginning. So from machine we are importing the pin and the ADC converter, then the import U time, X axis and Y axis connecting as an object to pin number 26 and 27, and the button is connected to pin number 16, pin.in, then the pull up resistor, and we are bringing that into the loop while true X value, alright, while true Y value, U unsigned integer 16, not, let's take the risk, button value equal to button, alright, okay. Let's check it up if this should work ideally, but in case I'll just increase the size of the terminal, because this is where we will be seeing the output, but we may not be able to see the full code. So maybe we may want to reduce. I'll try to open up another window for the terminal. Not sure if it is possible in Thani, but it's possible in Visual Studio, fortunately. Yeah, well, I'm not able to open the window here. Let me try if there is any settings to open a separate window. Option, manage packages, view files, inspector, variable, plotter. I don't think we will be able to open a separate window, guys. Anyways, we'll run the code and see what we get on the terminal. Is there a right click option? I don't think there is a right click option in the terminal. Anyways, let's run the code and let's see what happens. All right, let's cross our finger. Moment of truth. I am clicking this green button, run the script. I am going to save it on my Pico. It will show a pop-up message. You need to select Raspberry Pi Pico. All right. Once you select that, you need to name it. You can put any name you want, name of the file, but it has to end with .py. Oh wow, fantastic guys! This is amazing. At a one single shot, it works. That's great. I am surprised there is no error, nothing. Okay, let's take a look. So let me just switch over to my circuit and try to change the value and see if it works. All right, I'll just try to change the values here. I'll have to hold it because it's too fragile. Right, I'll just change the value. Oh, good. That's good. So can you see that, guys? The y-axis, if I don't do anything, the x-axis in middle, y-axis is in middle, and the button is not pressed. So let me press the button. There you go. The value changes. Now let me change the axis. There you go. It's showing the up button. Okay, I'll leave it. Now I'll change the axis again. There you go. Okay, let me bring it down. Alright, if I bring it down, it says left, which is wrong. So we can change that in the code, it's not a problem, it's just the direction. If you move up, it's saying right. Or maybe probably the device, the sensor itself is like that. So yeah, I think it's not the code issue, it's the sensor basically. It's not an issue at all. That's the way it's been designed. So we got to hold the sensor like this, right? This is the way it's going to be, left and right. So let me just press the button. Okay, the value changes. Perfect. Let me try right. Okay, left, up, down. Okay, it's correct, guys. It's perfect. The code is working perfect and our device is perfect. Fantastic. All right, guys. I hope you guys enjoyed this lesson. So, guys, do take some effort to modify this code and try to build your own project. I hope by this time we are on lesson number 13 already. I hope by this time you got a pretty good hands-on into plugging the circuit and getting an understanding of the MicroPython code. That is very important, right? That is where the magic happens. So do play around with the code and try to build your own projects, and do leave a message. Do reach out to me. I will help you one on one. All right, guys. See you. Goodbye.